Today we are joined by Jack Silva, Application Specialist. With that, I would like to welcome Jack.
Thank you, Sharon, and I want to thank all of you for joining our webinar today. Today, we will talk about how to get started running your ACCQPrep HPLC system. You will notice some controls and features in the various screenshots that I do not mention. These are advanced controls and will be discussed in a future webinar. We also will not discuss troubleshooting or solving problems. We will only discuss how to get the system running. If you have an ACCQPrep HP125, it is exactly the same except for the flow rate maximum. ACCQPrep systems have high pressure solvent mixing, which results in low dead volume ahead of the column and so have better gradient accuracy. The ACCQPrep HPLC has many options. For this class, we will cover the three most common injection options: manual injection, the Autoinjector, and the AutoSampler. I will discuss the differences because it does affect the way that you use the instrument. We will discuss operational differences between these injection options from the perspective of a new user. Some systems also have a column select valve and a solvent select module. There is very little operational difference here between systems. With the column select valve, there is less need to change a column. Simply select the desired column from a list. The solvent select valve means there is less need to change bottles to change solvents. We will begin with doing a basic run on the ACCQPrep. There are four main steps. Load the column and racks in step 1. Set up the solvents in step 2. I do the priming after setting up the column because choosing a method also loads default solvents into the method. Verify the solvents are the ones that you need for your sample, and if needed, change to the correct solvents for your sample. Step 3 is where column equilibrium and sample loading happens, and step 4 is where the column gets purified. One very helpful hint: before running your first sample for the day, it is a good idea to run a test sample to verify everything, including the column, is working correctly. I do this for all of my LC systems, including my analytical HPLC and SFC systems, so I can find problems before injecting my sample. I use Teledyne ISCO Universal Test Mix to test my systems, but you may use a test mix that works for you. The first step is to install the column if needed, or select it if a column select valve is installed, and select a predefined method. At this time, choose the correct solvent for your sample. Note that the solvents listed here use trifluoroacetic acid, TFA. I tend to do the priming now after loading a method because the priming uses the solvents defined in the methods. I can see that the correct solvents are being used. The last slide used TFA. Before entering this screen, I changed the solvent bottles. My sample that I want to run now uses just plain water and methanol without TFA. So now I can change the solvent names when I prime the sample. The solvents listed in new solvent A and B are stored in the system configuration, and we will discuss this later. I'm going to pause running samples for a few minutes to discuss injection options, since the instrument runs slightly different depending on the different injection options. You can inject samples manually with an auto, or you can use an auto injector, or you can use an AutoSampler. In all cases, make sure your sample contains no particles. All HPLC systems use an injection valve with a rotor. Particles in your samples scratch the rotor surface and cause it to leak. Filter your samples or centrifuge it so that you don't inject particles that damage the rotor. With manual injection, the sample will display the run requirement screen with options for loading the loop now or after equilibration. Loading the loop before equilibration allows the system to automatically inject the sample. You don't need to wait until the equilibration ends to inject the sample, so this saves your valuable time. To prevent losing sample, manually inject only 1/2 the loop volume. Depending on individual user injection techniques, some of the sample will be pushed further into the loop as illustrated on the left side of this slide. Note the run requirement screen. It tells you how much of each solvent that you need. The active solvent management will stop the pumps if the solvent level is low before you run out of solvent. Likewise, active waste management prevents spill. This run requirement screen is available for all injection options. You can do single or multiple injections with the Autoinjector. The maximum injection without sample loss is 1 ml less than the loop volume. If you have a 1 ml loop, you can inject up to 4 mLs, while a 10 ml loop allows you to inject 9 mLs. The syringe runs at such a speed to keep the sample entirely in the loop. At the end of the run, the system will provide instructions for washing the probe for the next sample. The probe and tubing volume is 0.45 mils, and the system accounts for this when doing multiple injections. To avoid any sample loss before the wash step, put only the volume of sample that you will run in the injection container so the system manages the probe volume correctly. This means that if you want to inject, say, 3 mils of sample, put 3 mils of sample into your vial and no more. Enter the total sample volume and then enter the number of injections. The system will calculate and display the injection volume for each injection. In this case, 0.5 mils for each injection. The AutoSampler is the most flexible option. It does single injections, multiple injections, and multiple samples using the sample queue. A new control is the sample position, the position of the sample within the sample rack. You may need to specify which rack on some systems. The fraction overlay, also seen for the Autoinjector, allows for fractions to be placed in the same fraction containers when doing multiple injections with time windows. If you have an AutoSampler, you can add your sample to a list of samples to be run. Depending on how the ACCQPrep is configured, each sample can use a different column and different solvent. Each sample can run a different method. If you have a system with a column select valve, select the column and then choose a method. You can also edit the method after choosing it. With solvent select valve, the solvent used in the method can be changed as well. Choosing injection parameters on the right links the physical sample to the method and also allows multiple injections. The next tube or next rack option tells the system to move to the next available fraction container or the next available rack for a new sample. If the sample runs out of fraction containers, it will stop until a new rack is inserted. With RFID rack detection, racks can be replaced while the system is running other samples, and the ACCQPrep will recognize the racks as new and use those new racks without stopping. Now that we know all about injection options, make sure the fraction racks are in place, press the start button, inject the sample by whichever means, and let the sample run. Now that we are done with a quick start and we have covered injection options, let's do something more advanced. We will discuss the gradient optimizer and how to use it. We'll talk about how to improve UV detection by selecting a wavelength absorbed by the sample, and discuss how to access old runs and adding new solvents that aren't in the sample list. Preparative HPLC method development is different from that for flash chromatography. As flash is typically normal phase chromatography, TLC plates can be used, and silica TLC plates run very quickly. The column retention time in column volumes is 1 divided by the retention factor for a flash system. For HPLC, method development is typically done on an instrument, either an analytical system or the prep unit. It used to take much more time, especially for a new user, than flash chromatography, but Teledyne ISCO has made method development much easier. We will describe the focused gradient generator using columns on the ACCQPrep. It is possible to use the focused gradient generator with an analytical HPLC, but the analytical system needs to be calibrated to generate useful results. The calibration procedure isn't difficult and will be discussed in a later webinar. However, it is described in Tech Note 52, available on the Teledyne ISCO website. The focused gradient generator can be faster than default methods and faster than other method development techniques. By using the focused gradient generator, you can save time, save solvent, and improve resolution. The Teledyne ISCO focused gradient generator starts with a fast scouting run that is finished in the same time as 1 or 2 TLC plates, but covers all possible solvent combinations. You can see whether the compound will have good peak shape. The focused gradient generator works with all manufacturers' columns, so if you have columns from another manufacturer, whether it be Waters, Phenomenex, or whoever, the focused gradient generator will still work for you. The gradient is much steeper than a typical runs, just because you want to get the calculation done quickly. The internal scouting runs in the ACCQPrep are all calibrated for you to use, and again, it doesn't matter which column or the size of the column. The target column might be the same as the one used for the scouting run, and this is useful if you have a preparative column with a unique chemistry and no matching analytical columns. You just inject a small amount of sample for the scouting run. Using the columns installed on the ACCQPrep for both scouting and purification runs ensures matching column chemistry. In this example, the peak at 5.8 minutes was chosen. This is the third eluting peak, and the calculated gradient is also shown on the screen. Select the column that you want to use and then select the scouting gradient method. If you don't find a scouting gradient method, it can be added in the configuration screen. Select the solvent that you want to use. Inject a small amount of sample. You can collect fractions so the sample is not lost. After the gradient is complete, press the focus gradient button. The new screen has instructions that you can follow. Select the peak representing the compound you need to purify with the touchscreen. Select the column that you want to use for the purification. It can be the same column used for the scouting gradient, or it can be a larger column. If a different column is chosen, it should be the same make and model as the column used for the scouting run, so the column chemistries are the same. In this example, the larger peak was chosen. The desired compound elutes in the middle of the focus gradient. The peak shape shows more sample was injected than the scouting run, so you can start with a very tiny amount of sample, and then you can use the calculated gradient to purify your compound. Users often ask if their system can be used with a particular solvent. A common question concerns ethers such as tetrahydrofuran, which are compatible with the system. There are a few solvents and mobile phase modifiers, compounds added to the mobile phase, that we don't recommend. Those few solvents are listed in the colored text. DMSO and DMF are useful to dissolve samples for reverse phase, but don't use them for mobile phases. Using inorganic buffers such as phosphate buffers or citrates you can run the system with it. They will wear out the pump seals a little bit faster, but they do not otherwise harm the system. We will discuss some of the other controls that you can use on the system. Some of these controls are duplicated on the main screen. For example, the sample name can be entered here or on the main screen. Likewise, peak collections such as collect all, collect peaks, or collect none are duplicated on the main screen. Collect all collects everything from the column, but the fraction collector will move to a new fraction container when a peak is collected. Collect peak sends the column effluent to waste except for detected peaks, which are collected in fraction containers. Collect none sends everything to waste. There are several basic detection options. The ACCQPrep HPLC uses a photodiode array with detection on 2 wavelengths. There is a primary wavelength, a secondary wavelength, which usually is not configured for fraction collection, and all wavelength collection, which is a composite signal of all of the wavelengths. If you have both a mass spectrometer and an ELSD detector, you might have only one single wavelength collection, as well as the all wavelength collection. There are detection settings that can be adjusted. Slope-based is based on the peak width setting. It is more sensitive with larger values. The numbers represent an estimated peak width. Narrower peaks change from baseline more quickly. It is also used for all wavelength collection, where the signal returns to baseline after 2 times the peak width. Threshold causes collection above the value entered in the threshold. Lower values are more sensitive. We will talk about the main screen at this time. Under the File menu, there are a number of items for saving files. File Open and File New are the most commonly used items. File Open is used to open an existing file for review. File New creates a default method from the currently selected column. You can save the run that you open as a PDF or text to a USB drive. During the run, you can insert or delete gradient points on the fly. Under Tools, you can zero the baseline and set up the configuration. Manual control is useful for many things. You can see if the lamp and flow cell are working well. Manual control is also useful for washing buffers from the system at the end of the day. The flow path will always include a column, but is optional to include the sample loop. Other manual control options include choosing the solvent composition, or just a single solvent to pump. Automation manual control is different for the AutoSampler and the Autoinjector. Both are used to wash out the sample loop and injection probe, while the AutoSampler allows the wash station to be filled using the Start Wash button. Filling the wash station before runs at the start of the day allows more accurate injection because the system removes all of the air from the injection tubing. The Instrument Configuration tab allows solvents to be added, removed, and selected. Solvent and waste sensing can be enabled. The Prep HPLC tab allows management of columns in the system. Press the New button to define a new column. A new column needs a name and column parameters such as particle size and internal column diameter and length. Set the pressure limit for the column. Some columns, such as chiral media, are only limited to 800 psi and are damaged if the pressure gets too high. The ACCQPrep will stop the pumps if the back pressure is higher than the column setting. You can also remove a column from the setting with the delete button. The next step is to define methods for the column. Press the column associated with the method, press the Define Methods button. You can select an existing method and use the Edit button to change it, or use the New button to create a new method. There is a button to define a scouting method for the focused gradient generator too. Edit the new method and exit from the method editor to save the method. We will end with methods to estimate how to set the UV detector for maximum sensitivity. The best method is to use a UV spectrometer. If you did run the sample on TLC plates with F254 coating and saw the compound as a dark spot on a green background, the compound absorbs 254 nanometer light to some extent. The equations in this slide allow a good estimate of the maximum UV absorbance for some compounds, and some examples are on the slide. I will pause here for a second so that you can take a screen picture of the link so that you can look up these equations for yourself. Do you have any questions? You may find us on Facebook, Twitter, LinkedIn, and YouTube, and you can scan the barcodes to access our channels on each of those social media. And thank you. And now we are open for questions.
Well, thank you, Jack, for sharing your expertise. And I would like to mention, Jack has provided our website on this last screen. And if you would care to, if you didn't have a chance to scan the QR codes for our social media, please feel free to go out to our website. At the bottom right-hand corner, you will find links to all of them. If you would be interested, please like us and follow us, which will allow you to be notified of all upcoming webinars. As Jack mentioned, we are now opening it for questions. Please enter any question in the Q&A function within Zoom. Thank you.
Okay, I see we have our first question, and it's asking, is there baseline correction? The answer to that is a little longer than you might expect. We don't measure the baseline and correct for it as we do on the NextGen 300. The NextGen 300 has a separate flow path where we can measure the solvent absorbance without running the solvent through the column. However, on the ACCQPrep, on the all wavelength correction, what you can do is set the peak width setting. And the peak width setting here does double duty. We measure the shape of the absorbance of the solvent. And then if a peak comes in, we note the change in the absorbance shape and we start collecting. If the peak lasts longer than twice the peak width, we assume that we are looking at some sort of baseline drift and reset the baseline until we see another change. So the answer is we kind of sort of correct for baseline, but it's making an assumption that something that is longer than twice the peak width is really not a peak, but is really a drifting baseline. The next question I have is about the mixing volume ahead of the column, because I want to scale from my HPLC system. And the mixing volume, that is the draw volume, the volume between the pumps and the top of the column. It's a total of 7 mils if you have a 5 mil loop. So the total volume is the mixing volume, which is only 2 mils for high pressure mixing plus the loop. The next question is, can the system be configured for both manual and auto injection without the need to replumb between different types of injection? The replumbing is actually very, very simple. You just unscrew the sample probe and screw in an adapter for a syringe. And so you can do manual injection with very minimal plumbing change. And when you tell it the injection type in the run requirement screen, you just tell it that you are doing a manual injection. So there's not much replumbing, but you don't have to take everything apart. You just replace one fitting on the injection valve. Okay, we have another question about the focus gradient generator. And the question is, do you have to use Teledyne ISCO columns for that? And the answer is no, you do not. You can use any manufacturer's columns and it works. And in fact, we've run it with columns other than C18. So we've run it with silica, and the customer had a diol column, and it worked very well. And some people have even used the focus gradient generator to come up with initial conditions for chiral columns.
Are there any other questions? If so, please utilize the Q&A function and Jack would be happy to answer. We will leave it open for another minute, and if we do not receive further questions, I will close out the webinar. Thank you.
Okay, we have another question. Can you speak to how to configure a new scouting method for the focus gradient for a generator for a new column? I am assuming that the new column is on the system, on the ACCQPrep. So what you would do is go into configuration, and then you would then use the the configuration screen and choose Prep HPLC. If the column is already installed, you can select that column and choose a new method and or edit methods, and then there's a new scouting method button that you can choose. If you are installing the column for the first time, what you can do is use when you're editing the gradients, there's also a scouting gradient button there that you can choose. If you're using most C18 columns or most columns, I like to set the initial %B for 5%. If you are using a C18 AQ column, you can start at 0% B. Okay, the next question is, I mentioned that the slope of the gradient was sharper than in most cases. Do we need to configure this, or is it done by the generator? The answer to that is we have done that. The reason why we make it sharper than most cases is it's only meant as a scouting gradient, not intended for purification, and we want to run it very, very quickly. The reason why we configure it is that we have determined what the retention time is for the compound for you. And for a 150 millimeter column, we set an elution time of about 6 minutes, plus or minus a minute or two, depending on the compound. So we know the apparent gradient delay that it corresponds to the gradient that we have set up inside the scouting run. Okay, to go back to the earlier question, you go into configuration, prep HPLC, hit define methods, and there's a new scouting method button in there, or you can, and that sets up the gradient. The reason why we have it as a button is because it is a special method where you cannot change very much. Okay, another question is, what is the minimum volume that can be injected with the AutoSampler? We say that we can inject 100 microliters, and that's what we can inject very easily. However, we've injected down as little as 10 microliters very successfully, and we do it pretty commonly. If you want to inject that sort of volume reliably, you have to make sure that the fill station on the AutoSampler is filled up. Another question, and I thank you for keeping them coming in, is what is the minimum amount of sample that you can run on a scouting gradient on the focus gradient generator. Usually for a 20 by 150 millimeter column, I tend to run about 1 or 2 milligrams if the compound has a decent UV absorbance. If the compound is very impure and there's lots of peaks, I might have to inject a little bit more.